use the formula variable value minus the mean divided by the standard deviation. So using this particular formula, so we'll just code this particular formula. Just refer to the code presented over here. We define the mean, and we define the mean like this one, that np dot mean x axis is equal to 0, return sum x divided by length of x. Then we define the standard deviation. So we had np dot standard x axis is equal to 0, and we return the standard deviation for that particular data set. Then we define the standardized underscore data return. We put this particular formula, the value of that variable minus the mean divided by the standard deviation. So then we took a variable x underscore std, and we store the standardized underscore data result into that particular variable at this particular place. So the first thing you have to do is, I'll give you a code. Here what you have to do is, here you simply have to type Colab as we did yesterday. Right. So welcome to the Google Colab. You have to open the Colab. So the Colab is just a repository that is being provided by the Google, so that we should have we can run the Python code at this particular place. So you simply first of all open the Google Colab, and from this particular place we'll be using the Jupyter notebook at this particular place. If in case you want to go into the details, you can go through this one. This is very simple tutorial related to a Google Colab. So it's a cloud-based service. It says you can pay as per you go. For current free session, it gives you some certain amount of CPU to use, some certain amount of GPU, and some certain amount of TPU to use. So you can learn about the Google Colab and the basics of how to run a machine learning program into the Google Colab using this particular tutorial as well. So after that, we'll start doing the code at this particular place. So I'll come back to my slide. So at the Google Colab platform, you have to run the same code which I'll be giving it to you after I'll be finishing up with the explanation, and the iris dataset will be there into the Jupyter notebook itself. We'll import a library. Yeah, so I forgot, the importing will be the same as what we did yesterday. So we'll be, first of all, I should have started with the same thing, importing the necessary libraries, right? And after importing, we should start implementing the PCA. So we should standardize the PCA, and then we should move on to the step number 2. So once we standardize the data, then we usually find a covariance matrix. So the covariance matrix will give us the variance between the different features that were there into our original data set, and we want to move towards the low dimensional data from the original data, which was having a very high dimensionality. So we calculate the variance using this particular formula. The covariance of x1, x2 is equal to the summation of this one, which we learned into the theory session. So we defined the covariance, we returned, and we had this particular code for defining the covariance, and then finally we capture it inside the cov underscore mat covariance x underscore std. And then after that, once we have calculated the covariance, we'll try to find the eigenvalues and the eigenvectors. So for finding out the eigenvectors and the eigenvalues, we usually do this particular piece of a code. So what you can do is, the first piece of code, you can simply type it into a block, you can run it, you can see the output of that particular thing into a Google Colab. I'll show it. Then you can write the second step. You can write the second step, that how to find a covariance, and after writing the covariance, you can see the results of the covariance as well. Then the third step is, you have to find the eigenvalues and the eigenvectors. So we define the formula for the eigenvectors, that is a standardized formula, and we coded it like this one, as shown over there into this particular piece of the code, where you have eigen underscore values and eigen underscore vectors, and is equal to eigen underscore the covariance that we calculated from the previous step is being given as an input to this particular place, right? So then max underscore abs underscore idx is equal to np dot arg max, np dot absolute eigenvectors, comma x is equal to 0, Then we have signs is equal to np dot sign eigenvectors. We put the same thing. We put the range over there. Then we calculate the eigenvectors, and after calculating, we have the eigenvalues at this particular place, and finally we print. So we print the eigenvalues and then we print the eigenvectors at this particular place. So we'll get an output of that. Then we sort that. So this one is computing. So what we are doing is we are doing two steps under it. We are sorting the eigenvectors into the decreasing order, and then finally we are selecting the top principal components that we are getting. So for example, PC1, PC2 and PC3. So for sorting the eigenvectors here, we usually write a code eigen underscore pairs is equal to np dot absolute eigenvalues. We took an array and then eigenvectors this for I in the range of length eigenvalues eigen dot pair dot sort key is equal to lambda x0 reverse is equal to tree. Since we are doing it into a descending order, that is why we are defining the reverse to be true. Then eigenvalue sorted is equal to NP array for x in eigenpairs, and this is equal to x1 for x in eigenpairs. Now we will finally print the eigenpairs. So this particular output will be printed. Then we chose the topmost principal components that we are trying to analyze from the eigenvalues and the vectors. So this is we selected, for example, only 2 in our particular case. So the original features that are there into the iris dataset was 4, and we tried to reduce the features to 2. So the number of the samples that were there into the original dataset, let it be the same. But right now we have just picked up the 10 samples and then we performed an experiment onto that one. Then the output of that will be the print w.shape will be printed. So you'll get a sorted kind of a principal components line, and then the dots that are circulated around it. Then finally, the step is you project the data onto the new axis. So you want to show that the final, okay, what I showed you, yeah, this. So this is what you will be getting as the final output. You transform the original data into the new feature space defined by the top k eigenvectors. So you choose just PC1 and PC2, and finally you plotted a graph. So plot.x label, you onto the x label you have this, onto the y label you have this, and then you have titles, total of variation. So this is how you will display the corresponding results. Okay, so these are some of the references. Now I'll show you the code. So all of you have opened the Google Colab. All of you have opened the Google Colab, yes or no? Not yet? Just do it as as shown onto my screen. You have to just do the same way.
Ma'am, screen is not visible.
Okay. Just a minute. Is it visible now? Is the screen visible now?
Ma'am, video is clear, but
Screen is not visible.
no, ma'am.
Okay, I stopped the video now. Now is my screen visible? The Google Chrome new tab.
No, ma'am.
At my end, it says that my screen is being shared. Okay, what I'll do, I'll disconnect and I'll stop and I'll connect again.
Okay,
Share.
ma'am.
At my end, it is saying that it's connected. Okay, I'll tell them to be done. Sir, can you please make Tushar as the panelist? Tushar can share from his side. Mine is still,
Okay.
I
Yes, ma'am.
disconnected and connected again, but
Okay, ma'am. Okay.
now I
Now
think,
it
is it,
yes, yes.
are you able to see my screen?
Yes, ma'am. Yes, ma'am. Now it
Okay,
is shared.
okay, okay. So what I'll do is I'll open my Google Colab. I'll simply just see, I'll open it, although earlier. So now I'm opening it Google Colab. Okay, so whatsoever the code I'll be giving you from this particular place, you just press upload. Okay, and then my code is being kept over here. So this is the Jupyter Notebook code. I just browsed and I uploaded the code over here. You can even create your new notebook and then you can start writing your code by yourselves. Okay, so since I already run it, so the text is already showing it. So you first import the pandas, you import from sklearn.datasets, you imported the iris dataset from this particular command from sklearn.datasets, import load underscore iris, import numpy, so it's a built-in into the sklearn library. Then import numpy as np, import matplotlib, that we already did it, and then from numpy dot this particular thing we imported the EIG. So now you first loaded the data set and then you saved it into an iris, and this is the data and this is the target. So the column names are the four particular column names that are there into the iris data set is the sepal length, the sepal width, the petal length and the petal width. So if you see the first,
Hello.
second, third, yes sir.
Ma'am, have you shared the code in the
No,
chat
no,
box?
what I'll do is I'll share the code onto the WhatsApp with you, and
Okay,
then you
okay.
can share it to the participants. I was just showing it to them. Okay. Sir, I shared on WhatsApp to you. You may correspondingly forward it.
Okay, ma'am. Okay, okay.
Please check in case you have received it.
Yes, ma'am. Received, ma'am.
Okay, sir,
Just
please forward
give
it.
me 2
Yeah,
minutes. Yes,
please
give me
forward it
2 minutes.
to them.
Yes, yes, ma'am.
Okay, so the first point is just if you run at this particular place, it will be simply giving you this particular output. For you, this particular output will not be depicted. This is the output that I am getting because I already run the code. For you, whenever you will be running your code, this particular block through this one, your iris dataset will be loaded and you will get an output at the bottom place. So this particular block of code will be executed and then you will see that I am being able to upload the data set. Since I've kept the head count as a 10, so only the 10 rows or the tuples are being uploaded over here. So here Share the screen. Sir, I hope the screen is visible.
Yes, ma'am. Yes, ma'am.
So, sir, at which particular step was I? Computing the covariance was completed. Can any of the participants let me know? Computing the covariance, finding the eigenvalue. Okay, I'll start explaining from computing the covariance again. So the first step was the standardization. So since this was the original data set having four features: sepal underscore length, sepal underscore width, petal underscore length, petal underscore width, and the target at this particular place, right? So then number of features are only four, and then the samples are this. So now we standardize the data using the simple formula that we did. So we wrote the code, and since we didn't display any particular output to be displayed, we simply will run this particular cell and this will be executed and our code will be standardized. Next, this block is computing the variance. Since I haven't printed, so nothing will be printed in, but the covariance will be computed. So now the next will be finding the eigenvalues and the eigenvectors. So I click on this particular run, and then since I had printed the eigenvalues and the eigenvectors, so the eigenvalues and eigenvectors will be. Even if you want to print the covariance matrix here, if in case you would have put a print command, it would have given you an output of printing the covariance matrix as well. Now then we sorted it into the descending order. So then we printed the eigenvectors. So this is what is being. So if I run this one, since I already was running it, so the output is already being depicted. If I would be running it, since you will be running it for the first time, so here you will be executing and then you'll be getting an output. Then you select two PC1 and PC2 eigenvectors. So since you want the dimensionality reduction to go to 2 instead of the initial features of 4, you just selected this and then you print w.shape, so 2.4. Now you plot the cumulative variance graph to show the variance of the data based on the principal components. So this is the number of the components and the cumulative explained variance at this particular place. And finally, you want to project onto the principal components. So PC1 and PC2 were the components and you simply projected it. And when you will execute this particular plotting the data onto the new principal components, you will be depicted with this particular graph. Okay, so you can simply see the blocks and you can execute the block. Another is whatsoever code has been given to you, just press onto the runtime and run all. So the whole program will be running into a single go, and the final output and the intermediate outputs whatsoever you were getting, wheresoever you had a print or you had a plot, will be depicted into the same window itself. Now, yesterday I was talking about where I was telling you that you can change the runtime environment as well. Okay, so you can change the runtime environment and I can change, just see the rightmost place, right? So I can have a risk and I can change the runtime type. Okay, so from the here, the CPU, T4 GPU, and this particular TPU is there. So these are into the free version, right? So these hardware simple CPU with T4 GPU and the V28 TPU. These are free if in case your dataset is limited. If in case your dataset is big, then you may require to execute on this one. Then you have to buy a licensed one. So right now for your experimentation purpose, if you change from a CPU towards a TPU, you again have to start a new session and you again have to run the code. And then only you will be able to see the performance, okay, it completed in what time. So internet is an important thing. Even if you are running it onto a CPU or a GPU and doing a comparison with a TPU, your internet connectivity time should not hinder this particular thing. So you have to assume if in case you are writing a research paper and you have to show the results that okay, whether the PCA or whether a variant of a PCA or some other particular machine learning algorithm was giving a better result for your data set, you have to make sure that switching from one particular runtime hardware to another hardware should give you the results that you are expecting. Okay, and the similar way as we calculated the performance matrix that we did it for the logistic regression, you can do the corresponding performance metrics which you might have learned into a particular session. You can even do that performance into the last part, you can append the code and you can do the performance evaluation also at this particular place. Okay. So now you please try it, and if in case any doubts, I and Tushar are there to help you out with. Stop. And Tushar, please open the chat box so that they usually place their queries into the chat box so that we can solve that. You can type your queries into the chat box. Yes, Sumi. Yes, Sumi. Unmuted. Should I speak? Okay. So the answer to your thing is that since I opened it, I'll again share it and I showed you. Okay. Just see my screen. Is my screen up, visible to you?
Yes, ma'am.
Okay. So here, when you clicked onto the Google Colab, you pressed onto the left hand side, bottom one. Okay. Please try to open it using this Google Chrome despite of an edge, then it would be easy for you. So from here, if you see at the left side where my cursor is, here is the new notebook. So you can even create your new notebook. So it's not that you simply, because since yesterday when you were trying to run it, you were finding some problem when I told you to copy paste it. That is why I told, okay, you just drag drop the complete code and try to run it. Here you can create your new notebook. Once you click onto the new notebook, then you will be able to run the code. So you will type by yourself. First point will be importing your libraries. So here you will simply start writing. Import, right? So here you will write import pandas as p, then pd, and then you can write, okay, from sklearn. So from here you can start writing the code. So first just write the block so that you can import the libraries. And then next you write the block where you can standardize the data. Next write the next step and please execute it from this particular block. Despite of clicking on runtime and run all, right? A better option is you write a block of a code into a cell, execute it, see if some error is there, rectify it, then execute the next one. I hope I am clear. There are different blocks, so just try to relate it. The step number 1, step number 2, step number 3, step number 4 and 5.
Yes, participants, are you getting any problem in running the each and every cell? If it is perfectly fine for you, then just you can ask some questions based on the theory. Hello, participants. Am I audible to you? Okay. You can write a code in a MATLAB also, but Python that has a very strong library. So you don't have to write each and every logic in the Python because libraries are there. So you have to write the code from the scratch in the MATLAB or in other language. But here in the Python, there is an option library. You can use this library, and strong library are available in the Python itself. Other participants, please give the feedback. Are you okay with this Python code? If you don't have any doubt in the theory and this code part, then we can wind up this session, and next session that we will start after 5-minute break.